Hello class, welcome to Geometry Lesson 5.3, which is all about medians and altitudes. By the end of this lesson, you should be able to find points of concurrency for the medians of a triangle and the altitudes of a triangle. So let's jump right in with example 1 and identify special segments in triangles. So AE is highlighted right there as the altitude. Okay, so the altitude, the thing that you want to know about that is it is always going to be perpendicular to the triangle. It sometimes does not happen inside the triangle, so you can see that if we look, our triangle is here in blue, but our altitude is outside of the triangle. That's because it has to be at a perpendicular angle to the bottom of the triangle, or a side if it's tilted. So if it's an obtuse triangle like this one, the altitude is going to occur outside of the triangle, okay? If it's an obtuse triangle, your altitude is going to be outside. And always, 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 altitude has the 90 degrees. The median, on the other hand, is the segment that bisects the side. So if we look, DB bisects AC, so that we have AB equals BC. So a median, middle, bisect, those all kind of, go together. Median, middle, bisect. Altitude, perpendicular, can be outside. All right, so I want you to look at this triangle and determine what is the altitude for the triangle and what is the median for the triangle. Good luck. Hopefully you said the altitude was segment CE because you saw that right angle. And the median is DB because you saw that it bisected side AC. All right, so the concurrency, sorry, I just stuttered there. The concurrency of medians, okay? I'm currently struggling with speech today. The concurrency of medians is also known as the centroid, okay? So where the medians all intersect, that is the centroid. And that centroid is 2/3 the distance from each vertex to the centroid. So AG is 2/3 of the entire line going across the triangle, the entire median. Just like GB is 2/3 of that entire distance from E to B. Just like GC, again, you go from the centroid to the vertice, is 2/3 of the whole distance from C to F. You're going to use that to solve things. So I put a little note at the bottom of this saying the centroid is the point of concurrency of the medians of a triangle. So let's look at this triangle up top and say, what is the length of segment JN in the figure? So if I look, at this picture, J to Q is 18. So from the vertice to the centroid is 18, and that's 2/3. So 18 equals 2/3 the entire length. And I want to know what the entire length is. I can set up an equation just like this and solve for x. So I could start by multiplying both sides by 3, and 18 times 3 would give me 54. And then I could divide both sides by 2, and I'm left with 27 equals x, or 27 units is the whole distance. That's one way that you can solve it. Another way that you can solve it is, I've had people before that like to simply split it up into thirds. So we know that QN would have to be 1/3, right? If JQ is 2/3. So what people will do is they'll cut that in half and say, well, half of 18 is 9. So that has to be 9. This is 9. And this is 9. So then 9 times 3 would give me 27 units. I'm okay with whatever method you want to use. You can set up an equation, or you could divide it up like that. Or if I would have given you a problem where I said, let's say we're maybe looking at ML, and I said that this is 5. If going from the side to the centroid is 5, then I would split the other side up, and I'd have 5, and I'd have another 5, and I would know that is 15 units. I'm okay with whichever method you want to use. I just thought I'd show you a couple different options. Now, another thing that we can do with centroids is if I give you a coordinate plane and 3 vertices, or a triangle drawn on a coordinate plane, you can still find the centroid without having to do distance formula. It's way easier than that, okay? So if a triangle has the vertices located at the following points, find the centroid of the triangle. So the way that you find a centroid on a coordinate plane is you say x1 plus x2 plus x3 divided by 3, because we have 3 points, and then y1 plus y2 plus y3 divided by 3. That is going to be your centroid. So let's try that out. My x, I'm going to say this is x1, y1, x2, y2, x3, y3. Be sure you combine your x's with x's and your y's with y's. Don't just say, oh, here's 3 numbers, I'll add those together, divide by 3. That's not how this works, but sometimes you guys do that. I don't know why. Add your x's. So I have 5 plus 3 plus 7 divided by 3. And then my y's are -4 plus 5 plus 8 divided by 3. So 5 plus 3 is 8. 8 plus 7 is 15. So I have 15 divided by 3. And then I have -4 plus 5 is 1. 1 plus 8 is 9 divided by 3. And if I simplify, 15 divided by 3 is 5. And 9 divided by 3 is 3. So my centroid is located at 5, 3. Okay? So make sure you write down that formula, or yes, just write it down. Don't say, I'm going to remember that, because you'll probably end up dividing by 2, because it's just like the midpoint formula. But you need to add all 3 x's, and since we have 3 x's, we're going to divide by 3. You need to add all 3 y's, and since there's 3 y's, we divide by 3. Okay, question 2, find the length of a median. Okay, so if I want you to find AD for the triangle, and we know that AE is 21. Go ahead and solve this. Good luck. Hopefully for this problem you ended up at 31.5 units. The way that I solved it was I cut 21 in half, and then I multiplied it by 3 to get the whole distance. If you have any questions or want me to explain that another way, please be sure to reach out for some help. All right, example 3, locate the centroid. So we have an artist that wants to balance a triangular piece of wood at a single point so that the triangle is parallel to the ground. Where should he balance the triangle? So something you should know about centroids is they are actually really useful in what you guys call real life or the real world, because the centroid is the center of gravity in a triangle. So if you ever try to balance a triangle on something, it is actually the center of gravity. So if you were trying to just draw a centroid, what you would do is you find the midpoint on each side. So here are my midpoints. And then you draw from the midpoint to the opposite vertice. And then if I was good at drawing, all 3 of those would have intersected at a single point called the centroid, or the point of concurrency, and that would be where that triangle would balance. That's the center of gravity for it. Okay, so we've talked a lot about medians. Now let's jump into altitudes. So the lines that contain the altitudes of a triangle are concurrent. So that point of concurrency is called an orthocenter. So we have a lot of names between yesterday and today. Yesterday we learned about circumcenters and incenters. Today we've learned about centroids and orthocenters. So an orthocenter, point of concurrency of the lines containing the altitudes of a triangle. So in this picture, I have all of my altitudes. You can see I have my right angles, and where they all intersect, point X, is my orthocenter. Okay, so if we're talking about orthocenters, there's a couple tricks with them. If you have an obtuse triangle, your orthocenter, where all three of the altitudes intersect, actually occurs outside of the triangle. Okay, because sometimes the altitudes end up being outside the triangle. You can see that there's one case where an altitude ends up inside the triangle, but if you're drawing all three, two of them are going to be outside. Then, if you have an acute triangle, you can see that it's inside the triangle. And if you have right triangles, your orthocenter ends up being one of the points, one of the vertices of the triangle. So obtuse triangles, orthocenters outside, acute triangles, orthocenters inside, and right triangles, it is at one of the vertexes, specifically the vertice with the right angle for the whole triangle. Then let's look at how you find an orthocenter with a triangle. So I copy-pasted from the book, so that way I can just walk you through it without you having to watch me write. So the first step, find the slopes of two sides of the triangle. You can pick any two sides, it doesn't matter which, but the book chose KL, so this purple one, and LM, this blue one. And your first step, find the slopes. So remember, slope is y2 minus y1 over x2 minus x1. Or you can count, it's your rise over run. Remember, if you're going down, it's negative. If you're going left, it's negative. If you're going up, it's positive. If you're going right, it's positive. So the slope of KL they found was 1 over 2. So if I went up 1 over 2, up 1 over 2, you can see I'm hitting the graph every time I do that. Okay, so that's my slope. And then the slope of LM, I'm going up 1, which is positive, but then left 1, which is negative. So my slope is a negative 1. So that's your first step. Find the slope of two lines. Then your second step is going to be to find equations that are perpendicular to each of those lines. The book uses point slope form, which we haven't talked about again this year. We talked about it last year. You can use either slope intercept or point slope. And you want to write equations of the altitudes that are perpendicular to KL and LM. So the way that you know which point to use to write your equation is, if I'm looking at KL, see, I've used this vertice and I've used this vertice. That means I need to use the forgotten vertice. So in this case, M. I have nothing to do with M, so I need to incorporate it somewhere. So M is at 312. And my perpendicular slope, so remember this slope, KL, had a slope of 1/2. So my perpendicular is going to be negative, and then flip your fraction, so -2. So here's my perpendicular slope. And then they chose to use point slope form to solve instead of doing the y equals mx plus b in solving. They chose point slope form, which is totally fine. Let's look at what that would look like. So it'd say y minus my y value, which is 12, equals my slope times the quantity of x minus my x value, which is 3. And then if I solve from there, I distribute that negative 2, so that I have negative 2x plus 6, and I can add 12 over to both sides, then combine my like terms, and one of my equations is y equals negative 2x plus 18. Then, if I'm trying to find the altitude that's perpendicular to LM, I see that I'm looking at LM, I'm using L and M, but I'm not using point K, so I'm going to use that 0, 0 to solve. And my original slope for LM was negative 1, so my perpendicular slope is going to be a positive 1. So I have that. And then if I have y minus 0 equals 1 times x minus 0, that's my point K plugged in. That becomes y equals x. So then what I can do is I can solve. I can set those two things equal to each other, or since I know y equals x, I can simply plug a y in instead of having x. I could replace that with a y and solve, and then I would have y equals negative 2y plus 18. I could add that 2y to the other side, and then I would have 3y equals 18 and y equals 6. And then since we know that y equals x, we know x also equals 6. A more common way for step 3 that you're used to is we usually get rid of the y's. So I had y equals negative 2x plus 18, and I had a y equals x. The way that we've been practicing this year is we just get rid of the y's, and I say x equals negative 2x plus 18. I can add 2x to both sides, divide by 3, and then I can plug that back in, and I would see that y also equals 6. So you can see that you get the same answer either way that you do it. I thought, this was something that was tough for some of you this year again, so I would show you the other way that the book explained it to see if that makes it a little easier for you. And then the orthocenter. Since all 3 altitudes intersect at the orthocenter, the intersection of 2 altitudes is sufficient. You don't have to do that third side. You just need to know where 2 of them intersect because you know the third one also has to intersect there. So the orthocenter is at 6, 6. All right, why don't you go ahead and try to find the orthocenter of this triangle. Good luck. All right, so for this one, hopefully you started by finding the slope of 2 lines. You may or may not have used the same 2 lines as me. If you did use the same 2 lines, then you should have ended up with the same equations. Remember the equation, you make the slope perpendicular and plug in the point that has not been used. So in this case, when I was finding the perpendicular line to AB, I had to plug point C in. When I was finding the line that's perpendicular to BC, I had to plug point A in. Okay? Then once you've found your 2 equations, set them equal and solve for x and y. So here you can see I set them equal to each other and solved for x and y, and I ended up with 10, 4 as my orthocenter. If you have questions, please be sure to reach out for help. I promise you that a question like that is on the test. So you want to make sure that you practice that. And then here's the quick summary. Median, remember, has the centroid. That's 2/3 of the way from the vertice to the centroid. And the altitude is the altitude where they all intersect is called the orthocenter. And altitudes on obtuse triangles can be outside of the triangle, okay? Make sure you remember that. If you have any questions at all, please be sure to reach out for some help, and I'd be happy to help you. Have a great day.